Hello everyone. In this video, we will find the solution of the problem which says a uniform wire of resistance 100 ohm is melted and recast in a wire of length double that of the original. What would be the resistance of the wire? So, we know the formula for resistance is R is equal to rho L by A. So that means resistance is depending on the material, the length and the area, right? So when the wire is recasted into a different length, so the dimension of the new wire will change. So that means L and A will change, but the resistivity will remain same, right? So it is given that R1 is equal to 100 ohm, and let's say after recasting the resistance will become R2. So R2 is going to be rho L2 upon A2. Also, let's say R1 was rho times L1 upon A1. So first of all, we will find the relation between L2 L1 and A2 A1. We know the formula for volume of wire is going to be, let's say V1 is pi R1 square into L1, and V2 is going to be pi R2 square L2, right? Since the wire is recasted, so the volume will remain same. So that means pi R1 square L1 is equal to pi R2 square L2. So pi will cancel out. R1 square L1 is equal to R2 square. Now it is given that the length is doubled in the new wire. So that means L2 is twice of L1. It is given. So we will place it here. So instead of L2, I'll write 2L1, right? So L1 will cancel out. So R2 will become R1 by root 2. Fine. If this is the relation between radius, then the relation between their areas will be A1 is pi R1 square and A2 is pi R2 square. So if we divide these two, A1 upon A2 is equal to, pi will cancel out, R1 square upon R2 square. So if I put the value of R2 here, so I'll get the relation between A1 and A2 as R1 square upon R1 by root 2 square. So this will become A1 is equal to twice of A2. Now putting the value of A2 and L2, so R2 will become rho times L2 is twice of L1 upon A2 is half of A1, that means A1 by 2, or rho L1 upon A1 into 4. So rho L1 upon A1 is R1, which is 100 ohm. So R2 will become 100 into 4, that means 400 ohms. So this is the solution of this problem.